I'm going to talk about building a read-eval print loop, a REPL, using modern technology. This document is a snapshot of the current experiment. The blue ovals are sub-processes, and the hollow arrows are WebSockets. The dashed line here is just a file watcher sampling a file on the file system, and this little dotted line says that this choreographer component spins off a sub-process to run something called cost2JSON. So what I've done at this point is I've built 4 sub-processes, and I arranged the windows on the screen manually. Again, we would want to do that more automatically in a real version of this stuff, but this is just really an experiment of how far can this stuff be pushed before it becomes useless. This choreographer item is written mostly in Python. I wrote it mostly with an LLM, ChatGPT and Claude. The IDE is just a browser window with very primitive HTML in it. Draw.io is the Draw.io editor. I give a reference to it. In this particular example, I'm showing how to compile drawings to code and run them. I make the drawings in Draw.io. Draw.io saves the drawing as an XML file. The XML is actually called GraphML. When we hit save, the file watcher recognizes that the file has changed, and it kicks off a series of events. One of the events is the spawn of a process that converts the XML file to a JSON file and throws away information that's useless to the rest of the compile cycle. Information like graphical XY positioning information, colors, stuff like that. Then built into the choreographer at the moment is the actual runtime system that runs the JSON code produced by the drawing converted to JSON. I've got a little video that I give a reference to in this document that shows how this works, and it also shows that to the human eyes it's instant on a moderately recent development system. And here we see the windows that I've set up for myself. There's an HTML window over here with with one input box and a couple of output boxes, and a leftover box from part of the experiment. This window over here on the left-hand side is the Draw.io drawing editor, and you can see me manipulate a very simple program with it. These boxes represent bits of Python code. The red box is just like one of these blue boxes, except that I made it smaller and I made it more red. And I'm calling it a probe. It's really just like a printf. And then the white rhombus is an input to the system. The blue rhombuses are outputs from the system. In this simple example, there's a stood out, which is a nameless port, a stood air, which is a port with a name with a Unicode X in it. And the software components have input ports and they have output ports. And this diagram shows that the input from the main input gets split off into 2 places. And then the output of the 2 boxes gets joined up and sent to the output. The WebSockets are used in a fairly simple way. We just do one WebSocket to go from the choreographer to the browser, and another WebSocket to go from the browser back to the choreographer. And what the payload is, a JSON name, value, set of pairs, mostly strings at this point. The experiment shows that this configuration of 4 processes doing some heavy sub-processing ran fast enough that we don't need to do any further optimization of this system. And it appears to be a viable way to set up a REPL using this modern hardware. In contrast, in the early 1950s, 1960s, 1970s, we built REPLs into languages because our hardware ran so slowly that we couldn't afford to spawn off processes. Now we can afford to spawn off processes, and we can afford to send essentially inefficient JSON strings back and forth and parse them and JSONify them. That all happens so quickly that we don't even notice. That's a viable way to set up a read-eval print loop. I had originally hoped that I could set this up in about half an hour. It's been several days that I've been working on it, but I've had lots of interruptions, so I've lost track. I think it's well over half an hour. I think that failed, but a lot of it was due to my ignorance of how to set up HTML screens, how to use the LLMs, and that sort of stuff. Other observations and conclusions. Number one is it really was fast enough. We can now change our meaning of what efficiency is. We can ask, is it fast enough for a developer to use on development hardware? And is it fast enough for non-developers to use on cheaper hardware? This was the main bias in the 1950s, 60s, and 70s. We optimized for non-developers, and we wasted developer time optimizing things that no longer need to be optimized. I believe that we can easily use other editors and other languages in this configuration. For example, we could spin up an Emacs and run a standard compiler in a spawn process. One of the things that I think we need to do is have an IDE that uses many languages and many paradigms, so we can get a specific syntax for each paradigm, which means we can drill down better and express ourselves better. This architecture of the REPL gives us a way to approach that. Something I found out that felt like a revelation was that I've used Unix pipelines where you get one input stood in, you get two outputs stood out and stood air, and that's not enough for doing component-based programming where you have the possibility for many inputs and many output. But it turns out that something like JSON does help solve that problem. We can just do key value pairs and produce text output that we can send around and parse and JSONify at will. These experiments suggest some other possibilities. One is that we can replace some of the parts by target hardware. And another one is that we can spawn yet another process for doing the run. We could possibly spawn off a process here and load it onto target hardware. So if we're developing, say, for an Arduino, a cheap Arduino, we might be able to put it in here and see how it's responding and still get the ability to write code for it and look at the inputs and outputs of the thing on development hardware while talking to it. That's not a fresh idea. We've been doing that with remote debugging tools, but this might be a simpler way to set it up. And it might be simple to set up WebSockets going to and from the targets. The other suggestion is that we can lift a bunch of the code out of the choreographer and move it into a sub-process here. That's the next thing that I'm going to try and see and prove to myself that everything, the read-eval print loop runs fast enough even when it's doing heavy-duty compiles. And if you want to look at this stuff, the code repository is listed here.